Given the function f that takes x and maps to 2x minus 3 all over x minus 2, where x is a real number and x must not be equal to 2. Okay, so I think we should try to say something about this condition that x should not be equal to 2. Why do we insist that in this definition x should not be equal to 2? Okay, let's say if we want to see if we put x equal to 2. All right, what do we get? We're going to have 2 into 2 minus 3 all over 2 minus 2. This gives us 4 minus 3 all over 0, which gives us 1 all over 0. Now, dividing by 0 is impossible. 1 all over 0 is infinity. That's why we insist that x should never have the value 2, but x can take any other real number. Okay, that said, let's go ahead now and answer our question. We're asked to find f of negative 2. F of negative 2, we come over there, we replace x with negative 2 all over negative 2 minus 2. Okay, this gives us negative 4 minus 3 all over negative 4, which is negative 7 all over negative 4, which is 7 all over 4. Okay, f of negative 2 is 7 all over 4. Then, what about f of 6? f of 6. Okay, now this actually means f of 6 written as such. So we're going to do the square bracket first, the expression in the bracket. So it's going to be f of, now f of 6 will replace x there with 6. So we're going to have 2 into 6 minus 3 all over 6 minus 2. This gives us f of 12 minus 3 all over 4. So it's going to be f of 12 minus 3, we have 9 all over 4. All right? All right, so we're going to replace x now with 9 all over 4 in that same expression for f of x. So that gives us 2 into 9 all over 4 minus 3 all over 9 all over 4 minus 2. This gives us 2 here, 1, 2 there, 2. It's going to give us 9 all over 2 minus 3 all over 9 all over 4 minus 2. Okay? Now, at the numerator here, we have 9 all over 2 minus 3. What is that? That gives us 9 all over 2 minus 3 all over 1. The LCM is 2. Okay? So we have 2 divided by 2 is 1, multiplied to 9 is 9. 2 divided by 1 is 2, multiplied to 3 is 6. So we have 3 all over 2 divided by, all right, at the numerator we have 3 all over 2. Now, at the denominator we have 9 all over 4 minus 2. So let's do that. Keep this aside. We have 9 all over 4 divided by 2 all over 1. LCM is 4. LCM is 4. And so we have 4 divided by 4 is 1 times 9. We have 9. 4 divided by 1 is 4 times 2. We have 8. So this gives us 9 minus 8 is 1. It gives us 1 quarter. It gives us 1 quarter. Okay. So we're going to have 3 all over 2 divided by 1 quarter. All right. So we have f of 6 is going to be 3 all over 2 divided by 1/4. Okay. Now 3 all over 2 divided by 1/4, we maintain the first fraction, we change this to multiplication, and we invert the other fraction. So that will see 2 here 1, 2 there 2, which gives us 6. So f of 6 is actually 6. Okay. Now, what about C? The C part, take the C part, f inverse of 6. Okay, f inverse of 6. To get f inverse of 6, the first thing to do will be to first of all find the inverse function. First of all, find the inverse function. And so it's a 3-step method. The first step is to let y be equal to f of x. Okay. All right. From here, we make x the subject, so we can cross multiply. This can be seen as 1, and so we cross multiply this denominator multiply to that numerator, and we have y into x minus 2 is equal to 1 multiplied to that is 2x minus 3. Open out this bracket, we have x minus 2y is equal to 2x minus 3. Remember, we want to make x the subject, so we'll bring the x terms together, things carrying x together. This is yx, this is 2x. So we take this one this way, it becomes, remember here it is positive 2x. When we carry it this way, it becomes negative 2x. So we have yx minus 2x. Now this is negative 2y. If we take it that way, it becomes positive 2y. So we write positive 2y, and this minus 3 was already here. You remember again, we're making x the subject, so here x is common, we can factorize out x. When we factorize out x, we're going to have x into y minus 2 is equal to 2y minus 3. The last thing to do is to divide both sides by y minus 2. Y minus 2, y minus 2. So that y minus 2 cancels off, and we have an expression for x, which is x equals 2y minus 3 all over y minus 2. All right? So from here, we can now have the inverse function. The inverse function now becomes, we replace this y with x, it becomes 2x minus 3, all of that divided by x minus 2. All right? That is f inverse of x. So to get f inverse of 6 now, we simply replace x with 6. It's going to give us 2 into 6 minus 3 all over 6 minus 2. This gives us 12 minus 3 all over 4, which is 9 all over 4. Okay, so f inverse of 6 is 9 all over 4. All right, let's take the last section of this question. F of f inverse of 3. F of f inverse of 3. We'll take note, we'll need the inverse function, okay? We'll need this inverse function. So f of f inverse of 3. Okay. Question G. F of f inverse of 3. Okay? Now this means f into f inverse of 3. Okay? So again, the first thing to do is to evaluate what we have inside the bracket. F inverse of 3. This is f inverse of x. This is f inverse of x. So we evaluate f inverse of 3. So we're going to replace x here with 3. We have 2 into 3 minus 3 all over 3 minus 2. So that gives us f into 6 minus 3 all over 1. So this gives us f of 3. All right? It gives us f of 3, and we know f of x. F of x is 2x minus 3 all over x minus 2. And so this will just be, we'll replace x here with 3. 2 into 3 minus 3 all over 3 minus 2. And this gives us 6 minus 3 all over 1, which is simply 3. Okay? So f of f inverse of 3 is 3. There's something that we know about functions. This is a function f, and this is its inverse, the inverse of this function. The composite of a function and its inverse will always give us the identity mapping. Okay? The identity mapping, we can write it as I, is a mapping that takes a variable x and returns the same variable x. So whatever this function carries, it returns the same thing. So that I of 3, for example, will give us 3. And this I is given by any function when composed with its inverse. Okay? Which is the same thing as the inverse composed with a function. All right? Which is the same thing as the inverse composed with the function. A function composed with the inverse is the same as the inverse composed with that function, and that gives us the identity mapping. Identity mapping is a mapping that returns the same argument that it carries, symbolized by I. I of 3 gives us 3. So that's what we're just seeing here. F and F inverse of 3 has returned 3 as the result. So F and F inverse are a form and identity mapping.